Okay, so you guys, we've already talked about reference angles, right? So familiar with, I know it's been, what is it, 2 days, I guess? Familiar with reference angles? Nod a little, maybe? This was where we had a bow tie and we went like this. We said, if you're in quadrant number 1, it's the angle right here. If you're in quadrant number 2, it's the angle down here. If you're in quadrant, it's down here. And that one, kind of. We remember this now, sort of? Okay, well, they all have a reference of 60 degrees here. So let's find out what their values is in our calculator. So all I want you to do is put your calculator, and their quadrant is listed. Okay, so now we're going to evaluate cosine at 60, 120, 240, and 300. Let's figure out what happens here. Okay, so make sure you're in degree mode. I tend to work in degrees while we're getting used to it, just because you don't want to have to think about two things, right? Radians and new material. So we'll slowly be converting over. Okay, so what did you get for cosine of 60 degrees? 0.5. Okay, how about cosine of 120? Negative 0.5. Okay, and 240? Negative 0.5. And should we guess? What's 300? 0.5. Okay, so this is why you needed to learn about reference angles. If you look in this picture, if this is my triangle, right? There's a triangle here, which is the same triangle as this one over here. They have the same angle. So basically, instead of having to deal with all angles from 0 to 360 degrees, the reference angle allows me to talk just about that small triangle in there, which they all share. That way I only have to cut my problem down to 0 to 90 degrees, okay? Because it's got to fit inside that right triangle. Then the cast rule tells me if my answer is going to be positive because I'm in quadrant 1, negative because I'm in quadrant 2 or 3, or positive because I'm in quadrant 4. So basically, this is saying, if you want to know the cosine of 240, this is a quadrant 3 angle. So for the cosine, it's negative. So what I can do is I can ask my calculator, I only need to think about this problem. It's the negative cosine of 60. So it's kind of seems strange, like we're doing extra work, but in the end, when we start solving trig equations and things, we've limited our search down to just 0 to 90. Everything else can be compressed into there. Okay, so let's see if we can get the hang of this a little bit. Let's try to rewrite the following angle. So positive and acute, this is just going to be the reference angle. Okay, so try and rewrite the cosine of 200 using the reference angle and the cast rule. Okay, so what's the reference angle for 200? 20 degrees. So if you were to do this one, you know, maybe you need a bit of a refresher, that's fine. So 200 degrees in standard position is over here. Okay, that means the reference angle is this piece right there. So if this is 180 right here, and this is 200, then the middle of the reference angle must be 20 degrees. Okay, so the reference angle is 20. Will this be a positive or negative angle where I've drawn it? Sorry, positive or negative number, the cosine of 200. It's going to be negative because the x-coordinate is negative. So I could rewrite this as the negative cosine of 20 degrees. Okay, how about 430? What would the reference angle of 430 degrees be?
70.
Good, 70 degrees is the reference. Is it positive or negative? Well, I guess let's start by saying which quadrant is 430 degrees in?
1.
Yeah, it's going to be once around and then stops in the first quadrant. Okay, so 70 degrees, 430 is positive, so I can just say this is equivalent to the sine of 70 degrees. Okay. So in fact, it's not just 0 to 360. We can take any angle you want and we can boil it down to its reference angle. So any angle, big as you want, we can rewind it until we hit the reference. So we only need to look from numbers 0 to 90. Okay, let's try one with radians and see how we do. 4 pi over 3. Oh, Lord. Okay, fractions and pies. Could it get any worse? Okay. Can you draw 4 pi over 3? No? Yeah, I know. Well, where did we use as a reference before to help us draw this? What was the convenient one? It's in the conversions too because it's so convenient. 180 degrees or pi as the length. So pi, this is like pi plus pi over 3. That's the way I like to think of it. So here's pi, and then 1/3 of pi would be to there. So this is where 4 pi over 3 is. Okay? So 180 plus another pi over 3. Okay. So the reference angle is in between the two. This is at pi, or if you like, 3 pi over 3. So what's the reference angle in the middle? Give it to me in radians. It's not so scary. Don't worry about radians. These are just fractions. Pi over 3. To get from 4 pi over 3 to 3 pi over 3, that's pi over 3. So the reference here is pi over 3. And looking at my picture, will this be a positive or negative answer?
Negative.
It's going to be negative, so I can rewrite it as the negative cosine of pi over 3. Okay, so that probably busted your brain. Give yourself a minute to think about it and try doing this one by yourself. Tangent of negative 2 pi over 3. Okay, so can we draw this? Let's try and draw it. So what's the difference between the negative and the positive angle? Yeah, it starts by going down. We go the other way, so we're going to go like this. So how far should I go?
Like 2/3 of
About 2/3 the way, right? Because this is 2/3 of pi. So my angle is going to be about 2/3 the way over, which is going to be somewhere around here. Okay? So what's my reference angle?
pi over 3.
It's a pi over 3. It's this angle in here. Between negative 2 pi over 3 and negative pi, that's pi over 3 again. So it's going to be a reference, pi over 3. And will it be positive or negative if it's down in this quadrant here?
Positive.
Yeah, it's positive for the tangent. So I could rewrite this as the tangent of pi over 3. Okay. Okay. So, you know what? I think we're going to take a break there. We'll worry about the rest on Monday when we come back.